That function composition, all it is substitution. So, an example is if I said f of x equals this function, and I asked you to evaluate it when x equals -3. So f of -3 is basically what they're asking for. Everywhere there's an x, I'm going to take that x out and put -3 in place of it. And then simplify. -3 squared 9, minus 6, minus 5. Sometimes it's not a number that you plug in. Sometimes it's actually a letter or anything, right? So when I say x equals a, this time I'm finding f of a, which means exactly the same thing. Everywhere there's an x, I'm going to take it out and replace it with an a. Minus 5. And then if you simplify that down, get rid of parentheses, it looks like that. So f of a equals that function right there. So we got this one over here. This one says x equals a plus 1. Same idea. I'm taking every x out and in place of it putting in a plus 1. So right here it's x squared, which means it's going to be a plus 1 squared plus 2 times x, but x is a plus 1, and then minus 5. I'm not going to simplify that out because I think you get the idea. I even have done something like asked you to find f of triangle. That means everywhere there's an x, I'm going to take out the x and put in place of it a triangle. Function. That means everywhere there's an x, you take that x out and replace it with whatever is inside that set of parentheses. And that's how we do our function composition. We're going to substitute for x another function. That's what it looks like. This is the notation right here. It's got this little, it's a little o. It's not a multiplication. It's a composition symbol. Right? So that means composition right there. So f compose g of x is how that's written. F compose g of x. O. And as far as translating it into a simple form, all it means is take g and plug it in to the first function. So you're going to replace the x in the first function with the second function. That's what it means. Here is f of x equals x squared, g of x equals 2x minus 5. So composition says f compose g of x means take your f function and replace all x's with the g function. Well, the g function is 2x minus 5. So what this is saying is take everywhere there's an x in f, right? Here's our function, and replace it with 2x minus 5. So originally, our f function looked like this. I'm going to take out both x's. So imagine me taking these out, throwing them away, and I'm going to replace them with this thing. Equals, this side said x. Instead of x, we're doing 2x minus 5 squared. And it's this square right here where it came from. This guy's where that square came from. So if I were to ask you what f compose g of x was, you would say 2x minus 5 squared. Let's try it with g compose f. So the difference now is g compose f means take the g function, this guy, and replace its x's with the f function. But the f function is just x squared. So essentially what this composition means is take your g function. So here's regular g of x And I'm going to take out these x's, right? Scratch those out. And in place of those, I'm going to replace them with x squared. So g of x squared is 2x squared minus 5, right? I replace this guy with x squared. It means that g compose f of x is 2x squared minus 5. That's a few weird because we're taking x out and putting something else in still with an x. Don't think about that. Think about, here's your original function, right, f of x. I'm going to take that x out, which just leaves a space, squared, and then I take a whole nother function and I fill in that blank with that other function. So it's like, I took the x out, now left the hole there. The hole gets filled with whatever the other function is. Whether it has x's in it, triangles, B's, money, whatever it is, if my function says this, you replace the x with that. Let's walk through this. Okay, here is f of x and g of x. This first one is f composed g, so it's always the first one is the one being plugged into. Let me see if I can do a little bit more color coding. This problem says to take f and plug g of x into it. Now g of x is the square root of x. So everywhere in f that I see in x, I'm going to replace it with square root of x. We've got f of x equals 2x squared plus x, but I've got to take the square root of x and replace each one of those. So I'm going to have 2, took that x out, squared, plus, took that x out, and I got an empty space there. So I've got 2 blank spots. We got 2 blank spots in there, and I'm going to replace them with the square root of x. So square root of x goes in place of that one, right? We replaced it there. Square root of x goes there. We replace both x's with our new function. And then you simplify. So we would say f compose g of x equals, now square root of x squared is just x. So 2x plus square root of x. And that was done. G compose f of x, which means inside g, we're going to replace every x with f of x. So f of x is 2x squared plus x. We're plugging that into g. So if g of x originally was square root of x, I'm going to cut that x out, right? And that means I'm going to replace it with this stuff. So g compose f of x is going to be the square root of 2x squared plus x. And you can't say okay, pulling the x out, replacing it with whatever the other function is. Okay, this one's a little bit trickier, right? F compose f of x still works. This one's saying, hey, inside your f function, plug itself in there. So f of x again is 2x squared plus x, which means in my original function right here, I'm going to take out this x and replace it with that thing right there. So it was 2x squared plus x, but I'm going to take out these and put parentheses parentheses in place of it. So I took those x's out. So I took the x out of there, took the x out of there. And I'm now going to plug f back in to itself. So 2x squared plus x is going to go here. And 2x squared plus x is going to go there. So when you take f and you compose it with itself, f compose f of x, you end up with this function. And I'm not going to multiply that. That's not what's important. What's important is that you understand to plug what into where. The function composition, let's circle there, that's all. Now, this is similar, but now we don't have the x's. We've got actual numbers there. Not a big deal, same idea. F compose G of 3 means take F and plug G of 3 into it. Well, to find G of 3, this means take your G function and plug in 3 for x. So that, I hope you can hear that. They might not last the night. Okay, so what I found here was G of 3 by plugging it into this function that's defined as G. From there, I could take and plug that value in to x, or sorry, to f. So instead of G of 3 now, I've replaced it with 9 because when I plugged 3 into my function, I got 9. Okay, to finish this out, you're going to take x and replace it with 9. It's just regular old evaluating now. That's 81 minus 27, or let's see if we can get this done before they start again. So this one says take f, plug G of 1 into it, which really means take G, replace its x with -1, find that value, and plug that back into f. So this is going to become f of 1. And if we plug that in to our original function, it will be 1 squared minus 3 times 1, or 1 minus 3, which is -2. This one now says G of f of 3. So f is actually getting plugged into G. Of x, that guy, replace all the x's with 3's and end up with 0, which means this guy is now G of 0. And when you plug that into the G function, you get 0 plus 3, which is 6. And if the rest of this one, 30 seconds or less, I don't get a bad video. G of -2. So inside here, let's just take G and replace the x with -2, -1. Now, going back to this original problem, that now means take G, that's this one, of -1. Again, taking the x out, plugging in the 1, you get -2 plus 3, or